Hello everyone, welcome to the KRANTI PHYSIO. Today I am going to discuss a very interesting topic in exercise therapy, which is pulley. Let's discuss. What is pulley? Pulley is a simple mechanical device which makes a task easier and less stressful. Pulleys can be divided into two types. First one is fixed pulley and second one is movable pulley. In fixed pulley, we can change or alter the direction to make our work easier or to lift a object. But in movable pulley, is used to gain a mechanical advantage. Whether we lift a heavy object, we can use movable pulley. The example of movable pulley is to lifting the trunk in suspension therapy exercises. In fixed pulley, the wheel attached to the surface that changes the direction of applied force. No mechanical advantage, that is, same amount of force is required. In movable pulley, the pulley moves along the rope. Wheel support the load. Effort is in the same direction as movement, reduces the force needed to move an object. Let's discuss about angle of pull. Angle of pull is the angle between the line of action of muscle and the bone it moves. When the angle of pull is 90 degree, then the muscle is most efficient. Why? There is mainly three reasons. That's why in 90 degree or when the angle of pull is 90 degree, then the muscle is most efficient. Let's discuss what are the reasons for that. The first reason is maximum torque. The first reason is maximum torque. When the angle of pull is 90 degree, then it will produce a maximum torque, which is a rotatory movement, and that movement causes the bone to move. Second reason is optimal force transmission. Then what are the optimal force transmissions? When the angle of pull is 90 degree, then the muscle force is transmitted most efficiently to the bone, which result in effective movement. The third reason is reduced wastage of force. When the angle of pull is 90 degree, then there is no force is used to joint compression or distractions. That's why all the force are used in the joint movement. So this is the reasons for why when the angle of pull is 90 degree, then the muscles is most efficient. These are three main reasons. Let's discuss a very important concept which is very important to us. I think everyone can understand my handwriting. Actually, I don't have a very good handwriting. Please adjust all this. What is anatomical pulley? When the angle of pull is deflected by a bone or any bony prominence, then this is anatomical pulley. I am going to give an example. This is glenoid fossa and this is flat. This is flat. There is no GT, bony prominence, but here there is GT and LT, and here the muscles, the deltoid muscle. Let's take an example of deltoid muscles. There is no bony prominence. Just an example, but here there is GT. So deltoid muscle is inserted here. Every muscles or joint have an axis around which the movement takes place. Let's take an example. Here there is no bony prominence, but here there is GT, which is a bony prominence. So here the momentum is lesser than this. Here the momentum is this. So we know torque is equal to force into momentum. So if we apply same force means F is constant. So when the F is constant, then torque is directly proportional to momentum. Then when the momentum is also increases, then torque will be increases. Momentum increases, then torque will increases. Then muscle efficiency also increases. So we can conclude that when we extend our momentum, then applying the same force or applying the same amount of energy, we can get very good output in our muscles, or the muscle efficiencies increase while we increase the momentum. Here in anatomical pulley, the muscle being deflected, then the momentum is increases. While the momentum is increased, then the torque will be increases. Then the muscle efficiency is going to increases. Then after the muscle efficiency increases, then we can apply same force. When we apply a less input, we can gain a greater output in our muscle. And there are some other examples of anatomical pulley in our body, like our GT or LT in our humerus, and our condyles of femurs, and lateral malleoli in ankle joint, and patella also. Let's discuss patella. First case, there is no patella. In second case, there is patella. So in quadriceps muscles, insert here. If there is no patella, the muscle is like this. But if there is patella here, then the muscle is going to like this. The muscle is deflected. So let's calculate the momentum. Here the momentum is this much, but here the momentum is like this much. So momentum is increases, then torque is equal to force into momentum. We can give the same force, but here the momentum is greater momentum. So torque will be definitely increases. So whether the torque is increases, then the muscle efficiency is also increases. So here patella increases the efficiency of muscles. So here the patella is anatomical pulley. Then that's all about pulley, types of pulley, angle of pull, anatomical pulley, and with all examples. Then if you have any doubt, then you can draw your doubt in my comment sections. Then if you want any other topics in exercise therapy, then you can suggest me for making video. If you enjoy my video, then don't forget to like, share and subscribe my YouTube channel KRANTI PHYSIO. Thank you to all.